Meanwhile, let me just give you a quick introduction about our mentor as well. So the topic of today, that's non-linear data structures, will be taken by one of our experienced mentors, Swati. Right. If I have to talk about her qualification, she has completed her engineering in computer science, and she has been her department topper. Right. The work experience, she have worked with Caresoft Global. She was a team lead in machine learning domain and worked with various AI and ML projects. About if you talk about her domain knowledge, she has, huge knowledge about deep learning, image processing, TensorFlow, GCP. She's a Google Cloud certified deep learning, machine learning, and artificial intelligence developer. Right. So she's one of the experience that we have, and she'll be taking the session for today. Swati, over to you.
Hi, good morning, everyone. So I just see that we have a few of them joining in, right?
Yes, we have people who are still joining in. So meanwhile, we can just ask them if they can put down any questions in the Q&A, or probably they want to discuss anything with you, they can take it up currently.
Sure. Okay, so before I begin with anything, I just want to get a quick introduction from the people around here. So if you guys could put up from where you guys are joining today, that would be helpful for me to understand. For any of your questions, you can use Q&A. Or for any, the chat option is also available, I suppose. Hi, Thama. Bhargav, right? Great. Yes, Keshav, Varshini. You could really type it down, You can write in the chat or in the Q&A what do you want to ask. Okay. So as we are aware of for the, the topic for our today's Guru class, I would really like to talk about what do you understand by a data structure? Anyone who can tell me, what do you understand by data structure? This class for March batch? It could be a class for March batch if you want to join us. Yes, but this is an FGC. It'll give you an insight of, some exciting new topics every now and then. How do we, take up our own sessions, with the kind of experienced mentors we have in our training team. Okay. So yes, it's pretty much for the March batch as well, if you want to come in and join us. Yes, Evan said the data structures determine how are the pieces of data they are structured. Okay. So also it's a storage mechanism, right? It's a storage mechanism that is that helps us to store and organize data, right? It is a way of, you could say, arranging data, yes, structuring of data, arranging data on a computer so that it can be accessed and updated efficiently. Okay. So when we say that it's, when you're saying that it's only for structuring, so it doesn't limit to still, just the structuring of data or to organizing of data, right? Achha, I have a question. How can we get certificate? Finish off with the session and then we'll see about the certificates as well, right? So data structure is not only used, it's an important part for organizing the data, but it's not only just limited to just, kind of organizing the data itself. It is also used for processing, retrieving, and storing the data. So there are different, you could say from basic to advanced types of data structures that are used in almost every program or software system that has been developed up till now. So it's not like this is a newer concept and it has not been in use. It's always been in use. It's always been in use in the real world as well as in the programming world. No application, no program or software system has ever developed without a DS. Okay, there has to be a way to store things around, right? And for that purpose, you need data structure. So to store, to process, to retrieve, and, work around with the data. Okay. So when we talk about data structures, then again, the two things come into it. And can you tell me what are the different types of data structures? Anyone who can tell me what are the different types of data structure? Linear, very well. And array, okay. It's again, yes, linear and non-linear. So broadly classified into two categories, okay. One is linear, another is non-linear. So it's broadly classified into two categories, linear and non-linear. Now, when I have here, who told me primitive and non-primitive, it's not data type. We call it linear and non-linear though. Okay, Shravan. When you said array, now can you tell me in which category does array fall into? Does it fall into linear data structure or non-linear data structure? Linear, very well. Yes, linear. So now you see that this linear data structure is again divided into two. That means you have a static data structure and you have a dynamic data structure. Now, what do you think? Array falls into static data structure or dynamic data structure? Where? Is array a static data structure or a dynamic? Static. And why? When you say static, why do you say that it's a static data structure? You don't know? Okay. So you see linear data structures, let's talk about linear again, and then I'll fall back to this static, okay? Because it's part of linear data structure. Now this linear data structure is a data structure in which each element, they are arranged sequentially, one after the other, or in a linear fashion, okay? Where each element which is there is attached to the previous and the next adjacent elements, okay? That's why it's called a linear data structure. Now the examples, or it's broadly classified again into two categories that you say is static and dynamic. Okay. Now static data structure is the one that has fixed memory size. So you give a size and that is fixed. It cannot expand beyond it. Okay. It is easier to access the elements in a static data structure. So the example of static data structure is array. But if you're coming from a JavaScript background, you know that JavaScript has arrays which are dynamic. So I'm leaving that thing behind. I'm talking in general about all the arrays which are there. Okay. Now dynamic data structure is again a linear type of data structure where the size is not fixed. It can be randomly updated during the runtime. Okay. So you can update the size over there as well. Means you're not fixing it up. You're not providing one fixed size that this is the only size and you cannot scale it up or down as and when required. So for dynamic, you can do that. Okay. And the examples are queues and stacks, which are the most common one, which you might have heard. Then comes the non-linear data structure, the important one that we have to talk about today. Okay. So now about non-linear data structure. So data structures where data elements, they are not placed sequentially. They are not in a sequential manner. Okay, like in a list, in an array, like a stack or a queue. So they are they are called as non-linear data structure. In a non-linear data structure, you cannot traverse all the elements in a single run. So you have to run through that particular, DSA again and again. Okay? Or maybe like repetitive traversals are required to get all the elements out of it. Examples, the most common one that you might have heard of is trees and graphs for nonlinear data structures. Okay. So a nonlinear data structure, again, because this is the important one. So let's start full-fledged with the today's agenda. Okay. Nonlinear data structure is one in which each element are not connected in a linear fashion. They're not connected. They're not, one after the other. Like in a linked list, you know that this particular element is here, the second one would be there, and so on. That is again a linear one, right? So in such a data structure, elements might be connected in a hierarchical fashion. Have you seen any hierarchy chart where you create a hierarchy chart? Or, like family tree, you create graphs. That is your nonlinear data structure. Okay? Or it may be non-hierarchical, like in a particular, you could say linked list. Okay? So nonlinear data structures have more complex implementation than their linear components. Okay? Because obviously this is not connected one after the other. The storage is different. You have the traversal is different. You have to keep tracks of a lot of things over there, right? But let's see how we are going to work on this today. Okay. Now, what is the advantage of, what do you think would be the advantage of using non-linear data structure? Any advantage of using nonlinear data structure? Advantage I asked, not application. Okay, so advantage means what is the benefit of using it, right? So I mean, like the benefit is that it uses memory very efficiently, okay, other than your linear data structure. So the memory efficiency is increased in your non-linear data structure. Now let's take an example to understand this even better. Suppose there are two people, let's say John and Sarah. Okay, both of them are two high school students. Their class teacher assigned them to a list, containing of the names of the faculties in their year along with their department. So for example, I'll take you to a whiteboard now to do this one. Excuse me for a moment. So that's, my camera will be off. Sharing the screen again. Okay, so there are two students. Okay, one is John and another is Sarah. Now, these are two students, and their class teacher, she's assigned them some, task and gave them a detailed list which consists of names of the faculties in their particular year. I mean, like who all of them are taking, their sessions along with their departments. So now what John did was he kind of makes a table consisting of the names of each, you could say, person along with his or her department and designation. So that is what I'm saying, that this is the work of the John. Okay? So maybe the name of the member and their particular designation or department. What he did was he made a list. Okay? For example, Jane, Maria, Martin, and maybe Jane is the principal. You know, Maria is, let's say, HOD or vice principal. Okay? And HOD for maybe like science department. Martin is just a, teacher. The role is teacher, and he teaches, let's say, physics, and so on. So he kind of made a table. Sarah, on the other hand, what she decided to do was to create a kind of like a chart, okay, or a diagram that will show all the faculties along with the designations, and also will group them into different departments. So for example, if Jane was the principal, so she's going to be at the top. Then the next thing comes is are the different departments. So let's say you have a department for science. So the HOD for that science, and then you have a different department, let's say commerce, and you have an HOD for that. And maybe like this is your Maria, this is your Anne. Okay. So she kind of now prepares a chart. So all the teachers which are in this particular department of science, they are here, and all which are in the commerce one are here with their particular, whatever subject they take. Like this could be Mary, Tabitha, Simon, Anthony. And now this, she could be taking, one could be taking physics, chem, maths, biology, and one could be commerce, and there could be few teachers for that as well. Okay. And then the respective subjects. Now, what do you think from the two of them that you see in front of you? One made a table, one made a chart. Whose assignment you like the best or is more understandable over here? Which one do you think is better? The table format or the tree format? Tree. It looks more organized, right? So it's because here, the student, she has represented the relationship between the faculties, while if you see from the table format, there the student has only provided a one-sided list that does not show who works under whom, and kind of doesn't give us more clarity. Okay, so John's list is kind of like a linear data structure, while Sarah's is a non-linear data structure. Okay. Now, to analyze the key points of a non-linear data structures, elements, they are not arranged sequentially. One element can be connected to multiple elements. There might be a hierarchical structure presentation, and memory is not allocated in a contiguous manner. Okay. Examples of them, we are already aware of: linked list. Then you have trees, you have graphs. Okay. Now, our today's thing is to talk about tree data structure. Anyone who can give me a one-liner on tree? What do you understand by tree data structure? What do you understand by tree data structure? So a tree is a non-sequential, or you could say non-linear data structure that is extremely helpful when it comes to storing data that needs to be found easily. Means the search operation becomes quite easy, okay, in trees data structure. So tree is a non-linear data structure that is extremely helpful in storing data that needs to be found easily, okay. It's an abstract model. It's an abstract model which helps to represent data stored in a hierarchy. Okay. A very common day-to-day example that you might have done when you were small, you know, in when we were in school, we were given to do an assignment which was to create a family tree, right? Have we done that? I mean, like I did, okay. And I've seen many people around, they're still doing those assignments. So to create a family tree where a chart, we've prepared a chart to, you know, kind of show the family history with our grandparents till us, right? We've done that. Or also, if you guys are into organizations, you might have seen the chart for the organization hierarchy, you know, who's at the top, the CEO, who are the SVPs or VPs, you know, and so on, right? Down to the last, or the, you know, the, you could say the zero level employees which are there, right? So a tree, again, you might know, it consists of nodes, okay, which has some data, and also there exists some relationship, which is the parent-child relationship. Each node, it consists of a parent, okay, and each node can have 0 or 2 children. So we say that each node it consists of a parent, okay, except for the first one, or the root node. Except for the first one, or the root node. And each node, it can have 0 or 2 children. Or 2 children, okay. So each element of the tree is called a node. So each element which is there on the tree, that is called a node. The top node of the tree is called the root, as it does not contain any parent. So that is the starting point. For example, if you're building out your family tree, I would say, if means your grandfather, you'll see that you are going to put him at the top, and then you're going to build it down, right? So grandfather who is at the top, that is the root level. Fine. So that is how the trees are made. Okay. There are internal and external nodes which are present in the tree. A node that has at least one child is called an internal node. A node that has 0 children is called an external node, or a leaf. Let me draw it out and show you. Like 1, 2, 3, 4, 5. This is the topmost. This is the root. Okay. This is the topmost. This is the root. These are your rest of the nodes. The node that does not have any child is the leaf node. Leaf node. The one that has child is called the internal node. Okay. These are the edges, you know, connecting the nodes. Then there are levels from the root till the last. Okay. How many edges are connecting? So this is your level 0. Then you have 1. This is your level 1. And this is your level 3. So the level of this particular tree is 3. Sorry, 2. Why I said 3? So it is 2. Okay. any part out from a bigger tree is called a subtree. Any part out of which is a valid tree in itself is a subtree, like this. So I've taken this subtree out from it. So this is a subtree. Okay. That is a subtree. So the hierarchy of the tree is represented by levels. The root element is at a 0 level and the children are at level 1 and so on. A node in the tree may have an ancestors and descendants. Ancestors of the node are the parents. Okay, like 3 has a parent 1, 2 has a parent 1, 4 has a parent 3. Siblings which are at the same level, like 4 and 5 are siblings, 2 and 3 are siblings. Then 3 might have children, so the children are over here at 4 and 5. Okay, these are basic terminologies. A tree can also have a subtree, which in itself is a complete tree, but present inside another parent tree. This is a complete tree, 3, 4, 5, but is inside another parent tree. The depth of any node consists of the number of ancestors. Okay. Now there are two more terms, which is depth and height. Okay. Anyone who can tell me what is the height of a tree? What is the height of a tree? Depth is something which is similar to level. Okay. What is the height of the tree? So height of the tree is the height of the root node to the deepest node. So root node is here and the deepest node is these. Are these. If there were more, then it's going to be that. So you start from the bottom. So for the height, you start from the bottom. You know that, right? Height at the sea level. You know that concept? So as you're going to move up the sea level height, it also increases, so it starts from 0 at the bottom. So let's say this is 0 at h equals to 4. This is the last node. These are the last nodes. Here the height is 0. On the next level, height becomes 1. And then at the root node, it becomes 2. So height for this is 2. Okay. What is the depth? So depth is measured from top till down. Okay. Similar to something like levels. It measures from top to the down. So at this, so then again, you're going to start from depth. For the first level, it is 0. Then the second level which comes is 1 and then 2. Okay. So this is kind of like opposite of each other. Then what is the degree of a node? What is the degree of a node? Anyone? Anyone? What is the degree of the node? Degree of a node is a total number of branches of that particular node. So, us node key of that particular node, how many branches are there? That is the degree of the node. Okay. So here the degree 0, degree 0, this is degree 2, this is again degree 2. How many branches it has? Okay. That is that particular degree of the node. Understood this? Now we have a poll coming up for you guys.
Yes, so we have the question right in front of you. The height of the node is the number of edges from the node to the deepest leaf. You just have to answer, is it a true or a false? It's a quick attention check. This will let us know how many of us are following Swati. So we need majority of them to answer it correctly. Repeat the question. The height of the node is the number of edges from the node to the deepest leaf. The options are true or false. Just about to end the poll. Okay, the poll has ended. All right, so I think it's seriously a treat to the eyes to see majority of, not majority, all of them have answered it correctly.
That's great. Yeah. So I'm like, it feels good that you all have given the right answer in the yes. So now I'm going to move on to the next part of it. Thanks, Ruby. So there are two types of trees which I wanted to discuss with you guys, which is a binary tree and a binary search tree. Binary tree and a binary search tree. So a binary tree is a one where a node in the tree can have at most two children. Okay. That means one on the left and one on the right. Something like if there is a node, it can have at most two children like this. This way of structuring data, it helps us to form a tree, and using this, you can write efficient algorithms to insert, search, and delete the values. So this kind of tree is called a binary tree. Now, what is a binary search tree? So it came from a binary tree only, the BST. It's a binary tree that stores the data in a sorted sequence. It stores the data in the sorted sequence. Okay. It only allows us to store nodes with the lesser values on the left and the nodes with the bigger values on the right. Okay. Let's say this is 10, the root or the parent. On the left, you are going to have values stored which are less than 10. So like 8. And on the right, you're going to have values which are greater than 10. For the whole tree construction, you are going to do the same thing. What is greater than 8? So 9 can come here. What is less than? Maybe 7. Okay. Again, for this one is less than is 11 and greater is 13. So this is the way a BST is being formed. Okay. So a binary tree is always a binary tree, but a binary search tree is always a binary tree, but a binary tree is not always a binary search tree. Means the vice versa is not true. Okay, but if it is a BST, that means it's a BT as well. Now, if we have to create a BST, okay, what are the following operations that we need to perform on that? Okay, let's say we want to create a binary search tree. What are the list of different operations that we need? We need in a search tree, we need to insert. Okay, so if you want to insert a new data, you might want to search for some data. So that would be the search operation. You need to find the minimum value of the tree. You need to find the maximum value of the tree. Or you might want to delete some value. So that could be remove. Okay. As each element in the tree data structure is represented by a node, so we are going to first create a node object which will store the key left, right, means left and right child. And each node will store its value and reference to the left and right child, just like if you've done the double link or the doubly linked lists. Okay. So the tree data structure, as I'll give you the gist, would be, let's say this is a node. So what does a node contain? A node contains a value, let's say 10. It contains a reference for the right child and then a reference for the left child. Similarly, you are going to do for each one. That is what happens. It's kind of like a doubly linked list. Okay? A node is kind of like a doubly linked list structure that we create. Fine. So let's move on to the programming part now. One moment. Where is it? Okay. I hope I'm visible now. So now let's start with creating a BST. Okay. So for a binary search tree, we first need to create that node. Fine. Now to to start with it, I'm going to do const. I'm using JavaScript for it. You can do it in any of the programming language that you're comfortable with. We already took a class on tree data structures on Python a couple of weeks back. So now we'll be implementing it with JS. Okay. So binary search tree. And here I'm going to create it as a function so that I can call it later, with all the values that I need. Now, to create a node again, so for that, const equals to the function. So in your node, you have the key, you have the left and the right. Okay, so this would be this dot key equals to key. And here I'm going to pass it. This dot left. For now, the first time, the left and right are, if it is one node that you're putting in, okay? So the left and right are null. And this dot, the right is also null. Fine. So this ends over here. Let root for the first time as well, null. All the other methods we are going to add inside it, okay? Other methods, like for the insertion, deletion, minimum, maximum, those things we are going to put it here. The method implemented in the tree data structure is a little complex and it relies heavily on the recursion technique. So there is recursion. Recursion means where a method calls itself repeatedly. Okay, that is your recursion. Fine. So when you want to insert a node into the tree, that means to insert a node into the tree, there are three scenarios that we need to take a look at. That means if there is no root element that you have to start, from the root itself, then the next is that you have to check if the value is less than the root, then the left node is empty and add it to the left, else recursively call the same function to descend one level and check again and add it and so on. The same thing you have to do if the value is greater than the root on the right node. Okay? So the right node is empty, then you add it. Else what you're going to do is you're going to descend one level down recursively and check again and keep doing it till the element is added at the right particular spot. Okay? Now to help us with the adding the node at the correct place, I'm going to create a helper function for that. Okay? So let insert, you can give it a name as insert node equals to function. And here I want the node, the pre-existing and the new node. Okay. Now, if the value is less than the current node which is there, so you have to check that. So if new node and the key means it's hold the value for it. The name could be anything. Do not confuse with that. So node dot key. Agar wo chota hai, if it is less than that, then what do you have to do? Now you have to check if the left is empty. Okay. So if node dot left is equals to null. Okay. Then what you have to do is you have to put node dot left equals to new node. Okay. Else, if this is not the case, then the next part, which is the else thing that you have to descend it down, right? Check for the descendants. That means it's a recursive call. New node, node dot left, comma, new node. Okay. So this is for the left hand side that you've done. Now the next part, else, you're going to check for the right hand side. If node dot right is equals to null. Okay. Now if the right is empty, that means node dot right is empty. That means that you can do new node over there, right? Otherwise, in the else block, you're going to check for the descendants. That means you have to do insert node again. Node dot right and new node. Okay. So this is your insert insert node. Okay, so this is the insert node that we've got. You can insert a node in the BST again. Okay, and let's write the code. For the first time we've done the insert node. Now you need the insert method again. Okay, so where inside which what you will do, you will call this insert node method. So finishing it off over here, I'm going to create one more insert. So this dot insert equals to creating the function with the key and let new node equals to new node key. Okay, so you've created a new node and you've called the constructor over here. Now, if no roots, then what you have to do is you have to put this new node as a root itself, right? If root is equals to null, okay, then root equals to new node. Agar aisa nahi hai, that means the else part. What you are going to do is you have to find the appropriate place for it. That means you're going to call this particular method, which is the insert node method, with the root as the current node and then the node that needs to be inserted, which is the new node. Okay. So this is your insertion operation. Have you understood this? After this, what you can do is you can search for the particular value, with the help of the key, you can search that. Now to search, again, we are going to write a helper function for that. This dot search equals to, and for that we'll have a key. We are going to have a node. So the node, for the first time, I'm putting the default value for it as root itself. Okay, if no element is there, so we can return the false or null or anything, something like that if you want to return. So if node is equals to null, there is nothing, then you just simply return false. Okay. Else you have to do the recursive part of it. So again, if we are going to check if key is less than node dot key. So the one key that we have given, the value, if it is less than the node value, then you have to search the left subtree. Okay. So you have to go and start searching the left subtree for that. Fine. How will we do that? How you are going to check the left subtree? It is again a recursive call, remember that. So you're going to do return this dot search key, and it should be node dot left. Okay, on this particular end. Then else if key is greater than node dot right. return this dot search key comma node dot the right hand side, right? Okay. Else you're going to return true. All right. So that's it. That's about. Then what about, removing the nodes? I'm giving you 2 minutes to implement the functionality for removing the nodes. Okay. Can we do that? 2 minutes to think, how will you remove a node? Can we think of how you're going to remove the node? My Chrome stopped responding. Give me a moment. All right, not to worry. I'll take you through it. So we've done till search, right? And what about the minimum and maximum? How will you find the minimum value and the maximum value? So then for that, again, it's kind of like search that you have to go through for finding the minimum and the maximum, that you have to give the leftmost descendant value. So in a tree, the minimum means that it's on the left in a BST. So you just simply have to traverse the left and find the last value from the left side. Same for the maximum value of a BST in a BST tree means that you have to traverse on the right part of the tree and give the end value which is there, okay, which should be the maximum value in that particular BST. That is the two operations, minimum and maximum. When we talk about the removal of it, okay, so when we talk about the removal, so for in removal, whichever node you or the value that you have to remove, basically you have to check whether it's on the left hand side or on the right hand side. So it's again a recursive call that we take in notice is that you check whether this value is less than the node value, the current value from which you are checking. If it is, that means you have to recursively go and traverse the left hand side. If it is greater, then that is the recursive call on the right hand side. Okay. So this is the whole implementation of your BST. Okay. Now, we have to do how to call this, how to insert values. So for the insertion of it, let's see, const tree equals to new binary, I think, search tree. Okay, we've created an, an object of tree, and then you can just do tree dot insert, call tree.insert on it. Start inserting the values. Tree dot. This is the start, this is the main code, which is going to help you insert the values inside it. And whatever values you want to insert, tree dot insert. Let's say 15. Okay. Now you can also do tree dot, remove, tree dot log, tree dot, kind of maximum, or the search operation. You can all do that. So you can do console.log, tree dot min. Okay. So we've got the value, that means 7. This is the minimum value. We can have more insertion operations over here. Okay. We can have this as 13, 3. This could be as 18. Run. So you'll see the value again over here, the minimum value you've got as 3. Similarly, you can search for the console dot. You can even search, for a particular key that I want to find, let's say 18. Okay. So I have got that in my tree and I've got a true. If I search for some value which is not in the tree, it should give me a false. False. Okay. This is what the implementation of a BST looks like. I hope you're able to take away and understand what tree data structure is and how it's used. What are the real world applications before I come to the end of it? Anyone who can tell me what are the real world applications, or where you've seen, or you can identify that, that was an application of tree data structure? Anyone? What do you think are the applications of tree data structure? What about the computer file system? Computer file system, the one that is it in a tree data structure, like you're in a C drive, then you are in the users, then you are in, let's say Swati Yadav, right? Like app data, local, that is also a tree data structure. The HTML DOM, if you worked on DOM, document object model, that is also a tree data structure. Sorting and searching cases are also, tree data structure where we use it. If you know about sets and map interfaces, those are also implemented through tree data structure. And if you're aware of databases, so you might be aware of a concept of indexing in databases that is also based on tree data structures, or B trees basically. Okay. Dictionary, decision trees, there is basically a lot, music players. So there is a lot applications of tree data structures and how it should be used. Now, basically, at the end of this particular class, you have an idea of what nonlinear data structures are. And in that, you've actually covered the trees ones, right? And we've seen an implementation of BST, as we've already done a B tree, binary trees in our last one. So now in this one, we've seen what is a binary search tree, how to implement that and use that. Okay. How they differ from linear data structure and what is the efficiency of it, right? Anything that you think, any questions that you have for me? So now let's take up a poll, and then then Ruby, you can take over the session.
Thank you so much, Swati. Just have a poll coming up on the screen for you. Just give us a second. Just 1 second and sorry for the delay, apologies. Just 1 second and you'll see the poll coming up on the screen for you. Meanwhile, I would just want to put it across that if you have any questions in regard to the session that Swati had conducted today about the topic or anything else, you are free to put down that question in Q&A and we will surely take it up. All right, so we'll have a poll that will come up. Meanwhile, I would just want to, let you know that we at Unikaksha helps you, get a proper counseling as to how you can start your career in IT industry. We have various courses that will help you with 100% job guarantee. These are the programs, which are in sync with the current industry standard. As you know, IT industry is very dynamic. So we have industry vetted curriculum that has been designed and you will be trained, at par to those standards. Right, so we have various programs. If you wish to know about it, how you can get a 100% job guarantee with various payment options. I mean, we do have a pay after placement options also for the students who are in the final year, maybe have just completed the graduation. So do let us know if you are really keen in knowing more about the courses that we offer. We have a poll that will reflect on the screen now. So if you're interested for a career counseling session, just key in a yes. One of us from the team of the counselors will give you a call, understand the requirement, and guide you accordingly. You have the poll right in front of your screen. Do you want to know more about your programs? You have two options. Key in yes in case you're looking forward to build your career in IT industry. As mentioned, we have 100% job guaranteed program wherein we assure you a good job in IT sector with various payment convenience as well. The poll is just going to end in a few seconds, so kindly let us know if you're interested to know more. All right, meanwhile, I have a question here from Bhargava. When did we get certificate for this course? So, all right, so if you're asking for a certificate for this particular Guru class, it will be mailed to you shortly. Once the session is over, you can expect the certification within 24 hours on your registered email ID. If you're looking for a course, then yes, you will have to get in touch with us. Let us know in case if you want more details about the course that we offer. I mean, today's session was a Guru class. There is a difference between the course and the session that was conducted today. So if you're looking forward for course, let us know in the chat or maybe in Q&A so that we can get in touch with you about it. All right, Ms. Bob, which is the next session you will start and when? So are we talking in regards to the same kind of session that is conducted now? Are we talking about the Guru class? If yes, then it is conducted every week on a Saturday at the same time, and you will be notified about the topic and about the topic and the timing. The timing are the same. Actually, it happens on the same day, the same time. However, about the topic and the invitation, you will get it shortly. So in case if you're looking forward to that, yes, you will be notified for it. If you're looking for a course, then yes, we have batches starting this month as well. Let us know if you're interested to know. Any more questions? We'll just wait for a minute before we end the session. So in case if you have any questions for us, do let us know through the Q&A. just wait for another minute just to see if somebody comes up with a question. All right, it seems nobody have a question. All right, great. Well, thank you so much for attending the Guru class today on a weekend. Your certificates will be mailed to you shortly of attending this particular Guru class. We will look forward to see you in another session. Thank you so much for your time. Have a great